Okay, so I'm going to be picking up where we left off on the regression tables. Here I've got, again, a sort of annotated version of the coefficients table here. We can get some of these in various orders, but we can just go with this order for now. So an easy one to get first is b sub 1, and that's this value right here. And how you do that is you just take the Pearson's correlation for this thing, or R, and which is 0.98 here, and then you multiply it by the standard deviation of y divided by the standard deviation of x. And so for this problem, that comes out to about 1.073. Once you have b sub 1, you can then get b sub 0 pretty quickly. You just take the mean of y minus b sub 1, which we just got, times the mean of x. And so that comes out in this problem to be this 8.996 number. The thing you can do anytime, but I just threw it in here, is just get the betas for each of these. Beta for the constant is always going to be 0, and beta for the beta sub 1, basically, beta for x, is going to be 0.98, which is the same as the R correlation for that he gave us in the table. Next, we can get the t of b sub 1, so the t statistic of this bottom row, and that is simply the square root of the F ratio, which we got earlier in the assignment. Yeah, that's a good way to save some time rather than going through and solving everything out. Then we can get the standard error of b sub 1 pretty quickly, and that is just 1.073, so this b sub 1 divided by the t statistic that we just got there, divided by 13.929. And that comes out to about 0.077. So next we can get this standard deviation for the constant, so standard deviation of b sub 0, and that is equal to the standard error for the estimate, which we got earlier in the assignment as well, times the square root of 1 over n, where n is 10 for this problem, plus the mean of x squared divided by n minus 1 times the variance of x. And so the mean of x in this problem is 11, so you just square 11, and then the variance of x, you just find that by squaring the standard deviation that he gave us at the start. So that is that one, and then the last thing to get is the t statistic for the constant, and all you do there is you take 8.996, the b value, and then divide it by its standard error, and that comes out to the t statistic. So for the coefficient, or the confidence intervals for a 95%, you take your b sub 0 from just this last table here, and then add plus or minus, or not add, but plus or minus the critical value from the t-table, like in the back of our book, for a t statistic with a degrees of freedom of 8 for a 0.05 significance level. Yeah, just look for 0.05 at the top and then go down the column until you find the row for degrees of freedom equals 8. That'll be a 2.3 here. And then multiply that by the standard deviation of b sub 0. And then for b sub 1 or x, you would do the exact same thing, same critical value, but just replace it with b sub 1 and standard deviation of b sub 1. Alright, and then for residuals, which the syntax didn't give us, but that's fine, it's really easy. He gave us these values. The mean of the predicted value of y will always be just the same as the mean of y that he gave us at the start. The mean predicted of the residual will be 0. The standard deviation of the predicted value will be just the sum of squares total, which we got earlier in the assignment, and then divided by the degrees of freedom total, which is for this assignment is 9. And then you square root all of that, and that comes out to this 6.63 number. Next, the standard deviation for the residual is so the sum of squares error, or sum of squares residual, which we got in this same table with the total, and then divided by this got cut off, but it's again that degrees of freedom total, which is 9. And then you square root all of that, and that comes out to this 1.74. So that completes the table. The second problem is to predict a specific score on y, or predict a score on y based on a specific score of x. And for this assignment, he wanted us to predict it based off of an x of 8. But yeah, so this is just the general steps here. So this is the standard error of the prediction. It looks awfully similar to this standard error of the estimate. The only difference is this little tick mark, apostrophe, whatever. That just means that it's different in some way. It's used for another purpose. So the standard error of the prediction equals the standard error of the estimate times the square root of 1 plus 1 over n, which again is n is 10 here, but 1 plus 1 over n plus the sum of squares for x is what this turns out to be here on the top. You can just take the variance that you calculate down here and multiply it by the n in order to get the sum of squares. And then, so this sum of squares of x is divided by n minus 1, which here is 9, times the variance of x. And if you haven't already gotten the variance of x, it's just the standard deviation that he gives us on the first page squared. So, and then once you've gotten this standard error of the prediction, you can get, you can predict your point of y, where you think it, like the midpoint of this range, would be represented basically just you plug in the numbers into a regression equation, and that is, so estimated y equals 8.996, or b sub 0 from up above, plus 1.073, which is the b sub 1 here. So these are just coming from here, and then plus the specific predicted value of x. So then you get your midpoint, like where you think, if there's no error at all, where you think the y would be based off of an x of 8. And then you construct like a range where you think 95% of their scores would fall, based like around this number that you just got. So 95% confidence interval equals the predicted y plus or minus, again, this t critical value, so it'd be 2.3 again, times the standard error of the prediction that we just got here. So not the standard error of the estimate, but the standard error of the prediction. And that'll give you, once you add that, that'll be your upper limit, and when you subtract that, that will be your lower limit, just like in this table here. So that should be everything. Yeah, that's the assignment. All right.